Good morning, students. In this video lesson, we discuss about dispersion of white light. This is glass prism. It has two triangular faces on the top and the bottom, which you can see, and three rectangular faces. Three rectangular faces and two triangular faces. Altogether, it has five faces. Now, when a white beam of light is made incident on one of the faces of this glass prism, it splits into its seven constituent colors, which you can see in the diagram. This is white light. It is passed through the glass prism, one of the rectangular faces of the glass prism, and while passing through the prism, this white light splits into seven constituent colors, which you can see here. Sir Isaac Newton was the first who noticed this phenomena, and he called it as dispersion of light. So the phenomena of dispersion of light was discovered by Sir Isaac Newton. When a pencil of white light is made incident on a glass prism, it splits into seven colors. This was first discovered by Sir Isaac Newton. Medium that separates light into its constituent colors is known as dispersive medium. Now, what is dispersion? The splitting of white light into its seven constituent colors while passing through a medium is known as dispersion of white light. You can see here in the diagram a white light is made incident, and when it enters into the glass prism here, it splits into its seven constituent colors, which further gets separated while refraction taking place at this face of the glass prism. When we receive this dispersed light on a white screen, we get a band of seven colors known as spectrum. This band of seven colors in its sequence we can remember by using an acronym VIBGYOR. Where V stands for violet, I for indigo, B for blue, G for green, Y for yellow, O for orange, R for red. So the sequence of colors in the spectrum of white light we can remember by using the acronym VIBGYOR. Now in the diagram you can see that it is the red light which gets least refracted and violet light gets most refracted. So splitting of white light into its constituent seven colors is known as dispersion of. Now what is the cause of dispersion? why a white light split into its constituent 7 colors while passing through a glass prism. A white light, the components of the white light travels with the same speed in air or vacuum. But as soon as it enters into a dispersive medium or in a medium, the different colors travel with different speed of light. Different colors travel with different speed of light. This is your prism, white light. Here it splits into its component colors. So when a white light enters from air to glass, the different colors traveled with different speed in glass. So change in speed of light for different colors is different, and refraction depends on the change in speed of light. Means refraction means bending of light depends on change in the speed of light. Greater is the change in speed of light, larger will be the amount of bending. So dispersion of white light occurs because colors of white light travels at different speeds through the glass prism. The amount of refraction depends on the change in the speed of colored light in glass. Since the different colors travel at different speeds, they are refracted by different angles on passing through glass prism. Because amount of bending will be different. The change in speed of light is the cause of refraction of light. The greater is the change in speed of light, the greater is the amount of bending. Since different colors traveled with different speeds, so change in speed for different colors is different. So amount of refraction, that is bending, will also be different. So when white light consisting of 7 colors falls on a glass prism, each color in it is refracted by a different angle, with the result that 7 colors spread out to form a spectrum. Natural phenomena related to dispersion of light is rainbow. After rainfall, large number of small water droplets remain suspended in the atmosphere, and when a white light passes through these water droplets, they behave like a tiny prism and disperse into its 7 constituent colors while passing through it, giving rise to the formation of rainbow in the sky. You all might have seen this kind of rainbow during raining season in the sky. A rainbow is a natural spectrum appearing in the sky after a rain shower. It is caused by dispersion of sunlight by teeny water droplets present in the atmosphere. A rainbow is always formed in a direction opposite to that of the sun. The water droplet acts like a small prism. They refract and disperse the incident sunlight, then reflect it internally and finally refract it again when it comes out of the raindrop. Due to the dispersion of light and total internal reflection, different colors reach the observer's eye. Some of the terms which has been used here, like total internal reflection, we will discuss just now. This spherical figure in the diagram represents water droplets. This is your water droplet. This is white light coming from the sun. White light coming from the sun. When it enters into the water droplets, here change in medium occurs. So what will happen? This white light splits into its 7 component colors. And at this point, total internal reflection takes place and the rays of light moves in this direction. Again at this point, refraction takes place. So the phenomena of light which are involved in the formation of rainbow are refraction, total internal reflection, and dispersion. So these are the 3 phenomena of light which are involved in the formation of rainbow. Now, what is total internal reflection? So when a ray of light passes from a denser medium, when a ray of light passes from a denser medium to a rarer medium, it bends away from the normal. So here you can see that theta 1 is the angle of incidence and theta 2 is the angle of refraction, and from the diagram itself it is clear that theta 2 is greater than theta 1 because here the ray of light is bending away from the normal. So if we go on increasing the angle of incidence, that is theta 1, angle of refraction, that is theta 2, will also increase. Now, for a particular angle of incidence, we may come across that angle of refraction is 90 degree. So the angle of incidence for which the angle of refraction is 90 degree, that angle of incidence is known as critical angle. So when a ray of light passing from a denser medium to rarer medium is incident on the surface separating the two media at an angle for which the refracted ray just goes along the surface separating the two media, or angle of refraction becomes 90 degree, that angle of incidence is known as critical angle, and If a ray of light is incident on the surface separating the two media at an angle greater than critical angle, that is theta 1 is greater than c, then the light gets reflected back into the same medium. This phenomena is known as total internal reflection, which we will discuss in class 10 also. So you will learn about total internal reflection in detail in your higher classes. In brief, I have discussed what is total internal reflection. Thank you for watching.